Okay, this video is going to introduce the if statement with multiple alternatives. Up to this point we have done an if statement that had just one alternative, one choice, and then if the condition is false, you just skip it. And then we've done the two alternatives, so you have an if and then an else, and that's all we've done so far. Now we're going to expand on that and just say we have more than two alternatives. This is going to introduce some new material here. And so as we look at this chart over here, we're going to use this chart on the magnitude of earthquakes, and it's going to be a way that we can illustrate multiple alternatives very well. And so as we look at this chart, a Richter scale reading, of course, that relates to the magnitude of an earthquake, and they're given a number based on the Richter scale, and that's going to determine approximately, or it's going to predict the type of effect or destruction that will take place because of that particular magnitude or Richter scale reading. And so as you look at this chart, in order to understand this chart, what this is saying is that if you start at the bottom, it says at 4.5 there's going to be damage to poorly constructed buildings. Now below that there's going to be little or no damage, and so that would be another effect, although it's you know, the effect is nothing, essentially negligible. And so really starting at 0 there's no damage. Alright, and at 4.5 and up there's going to be damage to poorly constructed buildings until it gets to 6, and then it says considerable damage to many buildings and some collapse. And then at 7 it starts at many buildings destroyed, and you know, so 7.2, 7.4, 5, all the way up to 8. And then at 8 it begins where most structures fall. So these are different sections here, different types of effect. Now if we want the program to display the type of effect on the area affected by an earthquake, then we want to look at and see what the different choices are here, which is going to be from this chart. And so we can see that the compiler is going to have 1, 2, 3, 4, 5 different choices with which to make as far as displaying what the output's going to be. And so we're used to 2 choices. Now we have 5 choices. And this chart helps give you what the choices or the alternatives, and we might say the branches, are going to be in our if statement. And so you'll notice that we're going to go, well, most structures fall is one effect. So that's right here. This is a choice. And we're going along with the way we wrote our code before, which I tried to show for people that are having a tough time with this, is to write down the choices first. Those are your branches, those are your alternatives. And so most structures fall, many buildings are destroyed, etc. and etc. No destruction. Okay, so these are the 5 different options or choices that the compiler has to make. It's either going to print this one, etc. Okay, so then we go, okay, well, what is the condition that must be true in order for us to say most structures fall? And so what would happen is then, and what we did in class is we had students write down the pseudocode for this. And so this would be a situation where it's 8 or more. So that's why we have greater than or equal to as our relational operator. And we're going to assume that the magnitude or the Richter scale reading is going to be stored in a variable named Richter. So this is the variable call for the variable that's storing the Richter scale reading. So for example, if this Richter scale reading was 6.2, we would write up here above it 6.2 because that's the return value of the variable call. And the compiler would go, is 6.2 greater than or equal to 8? Now then, what has to be true in order for many buildings to be destroyed? Well, Richter, if the reading is 7, as it says here in the chart, 7 or more, then you've got the many buildings destroyed. And on, and greater than or equal to 6, greater than or equal to 4.5, and then finally the last option, which remember we have if with no condition. That's the way it's always going to be. We're going to put that if at the end, or that else at the end, and it's not going to have a condition with it. And some students keep wanting to put a condition, a parentheses after else. Don't do that. This is going to typically be the last choice or alternative in an if statement. So we want to look at an if statement with multiple alternatives, just kind of the logistics of it, things to remember. First of all, notice the first line of an if statement always starts with an if. And you only have one if. Only one line of code is going to have the word if by itself on it. And notice the last line is else. The last condition, or I should say the last branch, is going to start with the word else. So these are your two branches that you will always have, an if branch and an else branch. I should say, as a general rule, else will always be last, if will always be first. Alright, so those are for whatever other choices there are in between the if and the else, we are going to start with else if. So in this case, there are 3 more conditions that we need to add to this, and we're going to start them with else if. That's just the way it goes. Alright, so now what we want to do, what some students are thinking, and they brought this question up in class, they were saying, well, what about this? I mean, if 6.3 is going to make this true and this true, so how's that going to work? I mean, that doesn't make sense for it to print both of these. And so we're going to look at that here. So if you look down on your notes, whoops, right below this, we're going to skip number 1 first, and we're going to go to number 2. How many conditions are true if the Richter scale reading is 7.2? And so if you look at this, 7.2, well, 7.2 makes this condition true. 7.2 is greater than 6, so it's going to make that condition true. And 7.2 is greater than or equal to 4.5, so it's going to make that condition true. It can't print all 3 because that would not make sense. And so what we say is that this, no matter how many alternatives, only one alternative will be executed. And that's something that you should write down. Okay, so if no matter how many alternatives you have in an if statement, no matter how many branches, only one alternative will be executed. No, only one branch will actually be executed. And so we would say then that there are, how many conditions? There's 3 conditions that are true. Then why is only one branch executed? And so what you might do for now, because we're going to explain this in a second, section 1C, what we fill in for 1C is going to explain why only one branch is executed. Okay, so that's something we're going to look at right now. So let's get rid of that. Okay, For each condition evaluated, each condition is evaluated to be true or false in order beginning at the top until one of the conditions is true. So each condition is evaluated to be true or false in order beginning at the top until one of the conditions is true. And its corresponding branch is executed. Alright, so let's take a look at that. You might have to pause the video if you don't have time to finish. So let's take a look. So what's going to happen is, let's take 6.2. If the Richter scale reading is 6.2, as we said before, write the return value. It's very helpful. Put that in the condition. The return value of this variable call. So is 6.2 greater than or equal to 8.0? Well, the compiler makes the decision, or it says this is false. It makes a decision. Since this is false, we skip this branch, the body of this branch. Alright, so then we go to the next branch. The compiler goes here, goes down, and asks itself now, is 6.2 greater than or equal to 7? Why is it asking if 6.2 is greater than 7? It's to decide whether or not to execute its corresponding branch. So this is false, and so it makes the decision, I'm skipping this one. And it goes on to the next one. Is 6.2 greater than or equal to 6.0? Well, the answer is true. And so therefore, now you see then that it's going to execute many buildings damaged and some collapsed. That's what it's going to execute. And then what it does, it actually skips the rest, is what it does. So this is how only one branch is executed. And it's because each condition is evaluated to be true or false in order beginning at the top, like we did up here, and until a condition is found to be true, which in this case, so this was false, false, this is found to be true. Once it finds it's true, it executes the corresponding branch and it skips the rest. So alright, so that's what we did here. And for each false condition, its corresponding branch is skipped. When a condition is found to be true, and this is what we'll say here, this is the key thing, C, which is going to answer this question in 2. When a condition is found to be true, its corresponding branch is executed, and the remaining branches are skipped. Alright, so if we look up here again, we see that once, so this was skipped, and then when a condition is found to be true, its corresponding branch is executed and the remaining branches are skipped. And that's why it only prints 1, because 6.2 is greater than or equal to 4.5, but it is built into the Java language that to skip once it finds a true condition. Alright, and so that's how that works. And then the final question is, why does the compiler evaluate Richter is greater than or equal to 8.0 on line 1 to be true or false? And this is a very important question. This is going to be a test question, because I think understanding this is very, very important. So be ready to write on that one for number 3. it evaluates, the compiler evaluates this condition to be true or false in order to make a decision. Because decision, you don't have to write this now, but because all the decisions by the compiler are based on something being true or false. So it evaluates this condition to be true or false so that it can make a decision on whether or not to execute its corresponding branch. Alright, that's how it works, and that's what I'm going to expect everyone to understand and to be able to answer. Alright, so that's it for this particular video.